Now, this is the second part of our video on the sound wave, and it will be based on vibration in string and pipe. Now, before we go on, let's define the term that we have under it. We are going to be coming across something about fundamental frequency and overtone, then harmonic. Then, what is fundamental frequency? Fundamental frequency is the frequency of the smallest sound that an instrument can produce. The smallest sound that an instrument can produce, the frequency of it is called fundamental frequency. That by the time you now force that particular instrument, when you force it, you apply more force on it, it will give you another kind of sound, and that one is called overtone. Then both overtone and fundamental are referred to as what? Harmonic. Therefore, the first harmonic is referred to as fundamental frequency, while second harmonic, third harmonic, fourth harmonic, and so on and so forth, they are referred to as what? Overtone. But both of them, both overtone and fundamental, are referred to as what? Harmonic. Now, let's start from string. If you have a string like this, tight at both sides, if you plug it at center, it will give you this shape, like this, then like this. Then what will now be the length? If you want to determine the length from here to here, it's very simple. Since this one looks like a circle in the stationary wave is lambda over 2, that is wavelength divided by 2. Therefore, here now, our length will be lambda over 2. Please take note. A circle is what? Lambda over 2. While two circles will give us what? Lambda. Now, if you increase the force on this one, that is, if you want it to give you another kind of sound different from the fundamental, in that case, it will now give you something like this. This is the length. By the time you plug it, it will give you something like this, which form two complete circles. And don't forget, if one circle is lambda over 2, then two circles, the length of it will be lambda. Now, this is L2 for the second harmonic. This one is first harmonic, which is referred to as what? Fundamental harmonic. Then this one is second harmonic, which is what? First overtone. This is first overtone. Take note. First overtone, but second harmonic. Now look at the formula. If you now force it more than that again, it will give you something like this. And if you look at it very well, a circle is lambda over 2. So we are now going to have lambda over 2 plus lambda over 2 plus lambda over 2. So the length here, L3, will give you 3 lambda over 2. And if you take note of this, the arrangement of the length, this is L1 fundamental, the second harmonic, this is what? Third harmonic, which is second overtone. Now let's see what will happen to the fourth one. The fourth one now look like this. If you look at it, this one is lambda over 2, lambda over 2, lambda over 2, lambda over 2. At the end of the day, you get L4 is equal to 2 lambda. Do you notice any connection or relationship between the L? You see that if you know the fundamental one, which is what? First harmonic, which is lambda over 2. You can still get the other one. This one, because one is here, that's how you can still get it. One is here, it means this one, lambda over 2 multiplied by 1. Then to get the second one, it will be lambda over 2 multiplied by 2. By the time you multiply this one by 2, you get this one. So if I want to get the third one, I will just say this one multiplied by 3. And you can see that is the lambda over 2. Then if I want to get the fourth one, I will multiply this one by what? By 4. So from that, you can see that all the harmonic, that's why they said all harmonic are present in string. All harmonic are present in string. And it's also present in what? Open pipe as well. So when we get there, you see all harmonic are present. We have 1, 2, 3, 4, 5. In closed pipe, it's not like that. Let's go there and see. Now, what of if you are now looking for frequency? you are not looking for frequency or you are looking for velocity, it's very simple. Just come back here, make this lambda the subject of formula, which is lambda is equal to 2L. And what is lambda? Lambda is equal to V over F. From our V is equal to F lambda, make lambda the subject of formula. It means lambda is equal to V over F. Then replace this one with V over F. So we are going to have V over F is equal to 2L. Then make V the subject of formula is equal to 2L. Depend on what you are looking for. So in case you are asked to find the velocity where the length and frequency is given. Now let's go to open pipe and see how it produces what? Sound. Now, the first thing is, what is an open pipe? A pipe is said to be open if both ends are open. But a pipe is said to be closed if one of the two ends is closed. Now let's do that of open pipe first. For open pipe, you have it like this. How does it form a vibration? So if you blow air through this place, it will come like this. Then like this too. And if you look at it very well, it looks as if this one is half circle and this is another half circle. So half circle plus half circle will give what? One circle. And you know that length of that is length from here to here. So length of one circle, half plus half, 1. The length of one circle will give us what? Lambda over 2. So this one will now serve as what? Fundamental frequency, which is the first harmonic of what? Open pipe. What of if you have before 6 months I did to generate overtone, it looks like this. Don't forget here I drew one line. Here will be 2. 1. Then the second one will come back to this place. Do the same thing for the other side. 1. Then what? 2. Then if you look at it very well, this one shows that this is one circle, this is half. Half plus half, 1. Plus this one making 2 circles. And 2 circles means what? 1 wavelength. Therefore, L2 for open pipe is equal to lambda. So what of the third one? You have the third one like this. So maybe I'm going to draw it 3 times. 1, 2, 3. Then do the same thing for the other side. 1, 2, 3. So look at it very well. We have this and this, 1 circle, making 3 circles. So add them together, lambda over 2, lambda over 2, lambda over 2 in 3 places. It will give you what? Therefore, L3 is equal to 3 lambda over 2. What of the fourth one? So get the fourth one, do it in 4. 1, 2, 3, 4. 1, 2, 3, 4. So if you look at it very well, we have half here. Then we have 3 circles inside, making 4 circles. Therefore, it will give us what? L4 is equal to 4 lambda over 2, which is the same thing as what? 2 lambda, which is equal to 2 lambda. So if you look at it, see that it takes the same shape as that of what? String. So you see that this first one, multiply this one by 2, you get this one. Multiply this one by 3, you get this one. Multiply this one by 4, you get this one. So which means in open pipe, all harmonic are present in open pipe as you have it what? Closed pipe. What of the, as you have in a string, what of the closed pipe? It looks like this. We have this. So one end is closed. Then when you blow in air from here, it will come to this place and it will go back like this. So one line was the first harmonic. Therefore, N1 here, don't forget, 1 circle is lambda over 2. Half circle. We now do what? Lambda over 4. Therefore, this one is lambda over 4. Yeah? What of that? And this one is fundamental. This is fundamental frequency for closed pipe. Then so, for first overtone, you draw 2 lines. 1, 2. You can see that it ends at the middle, not at the end like open pipe. Then 1, 2. Then this one will give you lambda over 2, while this one is lambda over 4. When you add it together, lambda over 2, therefore L2 is equal to So we have lambda over 4 plus lambda over 2. So we add it together. That means our L2 will be what? 3 lambda over 4. 3 lambda over 4. Now let's try to determine the third one, third harmonic. And don't forget, this second one is first over 2. Then third harmonic now. For the third harmonic, we have it like this. Close 5. 1, 2, 3. 1, 2, 3. So we have one circle. That is making 2 circles, and that is lambda. Well, this is half circle, making lambda over 4. So at the end of the day, we add it together. They are going to have what? 5 lambda over 4. So let's go to the next one. The next one is like this. That is the fourth harmonic. Fourth harmonic. 1, 2, 3, 4. Then 1, 2, 3, 4. So if you have this lambda over 2, lambda over 2, lambda over 2, lambda over 2, then lambda over 4. We add it together. L4 is equal to 7 lambda over 4. And do you notice something on this one as well? So if this is fundamental, then to get this one, because this is 1, you multiply it by 1. Now to get the next one, how will you get the next one? This one. Look at the relationship. It means I need to multiply the first one by 3. Then to get the third one, I need to multiply the first one by 5. Then to get the fourth one, I need to multiply the first one by 7. What do you think is happening? It means it's multiplications of odd number. Odd number. Therefore, odd harmonic. Odd harmonic. That is 1, 3, 5, 7, 9, 11. So I can determine what will be the what? Seventh harmonic. 1, 2, 3, 4, 5, 6. The sixth one, the seventh one will have what? 13 lambda over 4. It's very easy. Then if you are looking for frequency or velocity, use the same method as we did before. That is that about closed pipe and string. Now the next thing is how to determine the velocity. The formula for finding velocity of sound wave using closed pipe. When you have your closed pipe like this, don't forget that our L1 is equal to lambda over 4 for L1. Then you now determine the L2 too. Then the L2, when you determine L2, you are going to have, for L2 you have 3 lambda over 4. Then you now subtract L1 from L2. Therefore you have L2 minus L1 is equal to L2, that is 3 lambda over 4 minus lambda over 4. Therefore, this one you have L2 minus L1 is equal to, find the LCM, we have 4, we are going to have 3 lambda minus lambda. So it will give you what? 2 lambda. Therefore, L2 minus L1 is equal to 2 lambda over 4. And 2 lambda over 4, when you cut it, it will give you, therefore, L2 minus L1 will give you lambda over 2. Then cross multiply. When you cross multiply, you are going to have lambda is equal to 2 open bracket L2 minus L1. L2 minus L1. So, but if in the question you are asked to find velocity, now just remove this one like we did. Replace your lambda with F, velocity over frequency. You are going to have V over F is equal to 2 open bracket L2 minus L1. Therefore, V is equal to 2F open bracket L2 minus L1. So if you read the question under wave and they are giving you 2 different lengths, so suspect this formula, especially if frequency is given. So this is formula for finding velocity of a sound wave. Then another one is how to determine frequency of a sound wave using sonometer wire. So as you can see, so look at the diagram of speedometer wire. So from the experiment, it shows that the frequency vary inversely with what? The length of the wire. That is 1 over L. That same frequency, that is fundamental frequency, F naught, vary directly as square root of tension in the wire. Then the last one is frequency, that is F naught, fundamental frequency, vary inversely as square root of what? Mass. And this mass, don't make mistake, it's not ordinary mass, but mass per unit length. So if after you have converted your mass to kilogram, you must divide it by the what? The length given. So when you combine all this one together, so you are going to have F naught is equal to what? F naught vary as 1 over L, then square root of T over what? Over L. Where this constant, when you remove this one, you have to replace with constant. Our constant is what? 1 over 2. At the end of the day, you are going to have F naught is equal to 1 over 2L square root of T over L. That is the formula for finding what? Fundamental frequency. When you get your fundamental frequency, they can now ask you to find frequency of second harmonic, third harmonic, or second over 2. Once you have this one, don't forget, it's a string. It's a string which comprises of what? All harmonic. Just multiply, depend on the number of harmonic you to determine. That will be the end of the video for second part of sound wave. The third part, inshallah, will be on why question on sound wave.